Okay, apparently we're live. Hi everyone, welcome to the first ever Jozi.js online. I hope this is going better than me just staring at my screen and this is actually airing somewhere. But first, I'm going to start off with something that not many people know, not even some of the organizers of Jozi.js. This month is our 3-year birthday. We started in April 2017 and we're turning 3. And for the first time ever, having an online event. We never had to cancel any events, so that's why we thought we'd push through and do this no matter the circumstances. So based on the survey that we did earlier last month, we decided to carry on with these remote events. You all responded and said that we should stick to the same time slot, so we're trying and we'll see how it goes. We'd still like to thank our sponsors. Our sponsors have been great in supporting us even during this tough time, and they'll continue to support us, and hopefully in no time we'll be back at BBD sitting all together, drinking beer and eating pizza. Hopefully some of you have your own pizza tonight. I heard some people do. Cool. We still, even though we're an online event, have our code of conduct, and we still ask you to please abide by it. So it's very basic, but the main idea of it is just be nice, be constructive and respectful to people, and work together. So yeah, and don't be spammy. This applies to all of our chats and things that you see that we're going to try using now, as well as this little survey we had at the end. If you feel you're being attacked, we have a group or a council of wizards who you can contact for help. Twitter handles are all there. Any of these people that you can see on here will be able to help you with any concerns you may have. And tweet us, let us know how this is going. How Jozi.js Online will work. So we'll still have our 2 speakers with 30 minutes each. Because the live stream is about 20 seconds delayed, that's quite a long time. Immediate questions can't really be answered because we would interrupt the speaker halfway through something else they're saying. So please use the live stream chat to pose questions, or rather actually use Slido to pose questions. So Slido, there's the link over there. All of these links that you can see here are also available in the description of the live stream underneath. And you can use the links to ask the questions there. It will be better to ask the questions there so they don't get lost in the live stream chat. And you can also upvote other people's questions. And we'll go through all of the Slido questions at the end and ask the speakers to answer them for you. That's the event ID. The 86592 is the event ID. And yeah, and then at the end, we're going to have a feedback form because we want to know how this is going. We want you to let us know what we're doing right, what we're doing wrong, and all of those nice things, because this is a community event, so we take advice from our community. And lastly, if you want to try this online speaking thing, please submit a talk. Again, this link is also available in the description at the bottom of the live stream, so go check it out. If you don't have any ideas on the talk, contact us and we can help you come up with one. And yeah, so I'm going to hand over to our first speaker, which is Ryan, and he's going to be telling us about Elastic as a data store. So I'm going to stop sharing and Ryan is going to start sharing.
All right, welcome everybody. It's a bit weird talking into a screen where you can't actually see feedback from your audience. But we're going to give this a go and see how we can move through with this. So for those of you who don't know me, I'm like Mike, I'm a bit of a JavaScript nut. And yeah, I try to do everything in JavaScript, at least as a first pass. Cool, so today I will be talking to you about Elasticsearch. So recently I needed to do a proof of concept system for a potential new client. And one of the big things that was involved in this particular project was we needed to do a lot of full text searching, a lot of autocomplete functionality, searching through big blocks of or paragraphs of text to try and find matches in it. So immediately, since it was a proof of concept system, the idea of using Elasticsearch as the primary data store seemed like a fun adventure. For those of you who might not be familiar, generally what happens with Elasticsearch is people use it to supplement their existing data stores. So you might take the logs from your application and ship them into Elasticsearch. That's one of the most common use cases for it. And then what people also tend to do is they'll duplicate some of their data that they need to search through into Elasticsearch. And where did this all come about? So for those of you who've been around for a while might remember something called Lucene, which is up on my screen at the moment. It's still around, still kicking, made by the Apache Foundation, or at least owned by the Apache Foundation. And it's a way, it is the main engine that powers Elasticsearch, where Elasticsearch adds a whole bunch of nice wrappers around this. You can use Lucene directly if you want to just plug it into, let's say, an existing SQL instance and add searching on top of that. So Elasticsearch is great because it comes with a lot of nice ecosystem components. So you might have heard of the Elk stack. Now it's called the Elastic stack, which includes Elasticsearch, which is the data store underneath. Then there's Logstash, which allows us to take our logs and actually pump them in. There's the Beats framework, which basically on a heartbeat will send information to the server. So this is very useful if you want to check metrics around like your CPU usage, your memory usage, disk space, that sort of thing. You can build your own NOC center with the whole Elasticsearch. And then on top of it, for visualization, we've got Kibana. And most of this is actually all free. The alerting that you can set up on top of Kibana, which basically will tell you if you're running out of disk space or send you emails on certain conditions, I believe that's a paid-for service. But for the most part, you can get all of it for pretty much nothing. So I currently have it all running in a Docker Compose file. All this code will be sent. It's all open source. It's on GitHub. Feel free to ask questions, leave an issue, or use it in your system. Up to you. Basically, I wouldn't run it as a single Docker instance in production, though. So you probably want to set up more of a clustered environment, even if you are going to use Docker or Kubernetes, because as we all know, that solves all the problems. So what I've got running in this compose file is one instance of Elasticsearch. And this was pretty cool. Somebody showed me this the other day. If you have an env file, you can actually read your environment variables directly into your compose file. So you can inject those in there. Very useful when you're deving on local. I set up a bunch of cores options and stuff so I can just test. And then to show you some of the tooling around Elasticsearch, what I've got is a few of the UIs on top. So those of us who are, let's say, from the Microsoft SQL background would be used to using SQL Server Management Studio. If you're a Mongo person like me, you're used to RoboMongo. You know, at the end of the day, if we're going to use this as our primary data store, we want some sort of visualizer so we can see what's going on while we're busy writing our code. So I've got a few of these that we can use. So we've got Elasticsearch HQ, Deja Vu, and of course, Kibana. All right, so Elasticsearch itself runs as a bunch of REST-ish APIs, which is quite interesting. So it's not like, you know, in SQL where you've got name pipe connections or anything like that. You're basically able to talk to the database using basic auth in the URL. if you've turned it on, and you can hit these REST APIs. So this is what it looks like when your cluster is actually up and running and you hit it with a web browser. Now, like with any data store, if you are going, you do not want to expose it to the internet if you can help it. This public interface should not be public. It should be, in your sealed data center, and only your actual API should be able to talk to it. Just good practices. Cool. So I've got Postman open over here because I don't think you all want to see me typing random stuff into my browser. The collections for this, let me just zoom in. Can't zoom in. There we go. So this collection itself is also checked into the repo, so you can play around and see how it goes. So one of the reasons why I say it's REST-ish is because it doesn't follow necessarily the traditional REST guidelines that you would use, but you interact with it with gets, posts, puts, and deletes, and using the path parameters and a bunch of query strings. So the first thing, if we hit the same endpoint I hit in the browser, we get back our JSON. And this is basically just telling us some information about the cluster itself and what version in that it's running. Another reason you don't want to expose this to the public, you don't want to leak information about your underlying infrastructure. One thing we can do, like the normal cat command in terminal, is we can find what indexes actually exist inside our database or data store. So an index is kind of analogous to a table or a collection in Mongo. In earlier versions of Elasticsearch, you could think of an index as an application and have multiple of them running on the same cluster. And you could then do custom types inside each of those indexes. And those types would be your collections. That approach seems to be heading towards the deprecated side of things. And it seems now that you would instead create a cluster per application and use the indexes actually as your collection. So you can see I've got a table of results over here. I've got movies, manufacturers. Then Kibana's created its own index in here for managing the stuff it needs. And there's another bunch of, like Elasticsearch's own internal one, and I've created one for meetings and people. I'm going to show you how we can just use these REST APIs to directly interact with the database. So I can delete the index. So if we go back and say get a list of indexes, you'll see movies is no longer there. So yeah, there was no confirmation dialog on that because it's just a REST request. So you want to be careful running arbitrary REST commands against your production data store. So the following movies and REST calls are adapted from a talk which I'll send a link out to, which was on Udemy. And so the author put a really good course together that I highly recommend. It seems to be targeting a bit more of an older version, but hopefully he'll update it soon. So in order for me to create the index, all I need to do is send an empty body request to the database or data store / the name of the index I want to create. And we will get back the fact that our command was acknowledged. And because it's in a clustered environment, you can do different write concerns. You can say, when executing this command, I want to make sure that it executes on at least 50% of the shards or all of the shards. So you can set all of those on the way in on your request. Then what Elasticsearch is it has automatic schema type things that happen in the background, but you also have the ability to control how that schema looks. So if for those of you who are familiar with JSON schema, it's fairly similar to that. And here what I can do is I can say, for movies, I'd like to set up the mapping or the schema. Important to remember is these are the properties I'm explicitly defining. Any properties I don't put on here, they could still be stored in the data store. It's just not going to index them in the way that you define. It might choose to index them automatically. I believe there is a way that you can say only allow these properties, but in general, you're going to want to enforce your schema using JSON schema on the API side of the world. So I'm going to just send this request through. and acknowledge true. So it tells me, yep, cool, I've set up that mapping. I can confirm it by doing a get to the same endpoint. And that just gives me back the fact that, you know, we've got genre, the ID of the movie, the title, and the year. The interesting thing you'll notice here is if you look at genre, it looks just like ID, but any of these could be a nested object or an array of those keywords, which is a bit confusing at first. So I'm going to show you how we create a movie. So you need to post to, or you can do a put to _doc after the index, and then you post the ID in the actual path. So the movie I'm going to create has got that ID. Doesn't have to be a number. I've set it as integer, but you could have it as a GUID or a string. And I'm going to post through multiple genres for this particular movie. And that gives me back a result, which has more properties on it than I posted through, which also, when you start off at first, is a little bit weird. The interesting thing, it'll give you back which index it was in. We know this because we posted it in. Same with the type. So this refers back to the type I was talking about earlier, how in previous versions, and if you set certain options in this version, you can store multiple types inside the same collection. And we've got versions of the docs. When I first started out, I thought that, oh, wow, this is really cool. It's going to save multiple versions of my doc, and I can refer back to earlier versions. But that's not actually how that works. This is more for concurrency. So I'll show you in a little bit how that works, where you can say, go and run this replace or this update, but only where the version number is actually set to that. We've got the result and the number of shards that it worked out on, and a sequence number and a primary term, which also it uses internally, because version is now deprecated for concurrency control. You now need to use a combination of these two factors. So yeah, it seems like a lot of active dev happening on Elasticsearch. Once we've created it, we can then do a get, and we still have the extra properties that it's storing internally on there. So you might want to strip those off in your API, or if you're going to allow for optimistic writes, or you can actually do that using the properties that are provided. We can also do replaces. So when I did a get, you'll see I get back the fact that the sequence number is 0 and the primary term is 1. So if I pass in sequence number as 4, if sequence number, and if primary term equals 2, which don't match, I should get back an error telling me I've got a version conflict, which is quite nice, because then you get your optimistic concurrency built in. So let's set that, I think it was 0 and 1. Cool. So now I've replaced it with this body, which says Interstellar Potato. If we go and get the movie again, we now have an updated title. So we can do creates, we can do retrieves, we can do updates, and we obviously want to be able to do deletes. So we can just simply do that. If I go back to the get movie, and it's gone. The interesting thing, it does give us back a 404, not a 200 with an error, which is great. You know, all the good stuff that you want. Let's not save those. I don't know what had changed. The other interesting thing is there's a bulk API that you can post to, which is very useful if you're going to send through a bunch of documents at the same time. The format is weird, though. So you got to send through with the header, you know, application JSON. So we've set it as raw JSON. But if you look, Postman is complaining because there's no commas between these, and it's not nested in a whole object. What it does is it uses the new line characters in combination with the JSON object. The first, and in each of these is a pair. So in the index movies with ID that, create that, the second row. And you'll see that it does those for each of the pairs. Just ignore the whites, the word wrapping. Cool. So if I send those through, I get a response back, which tells me how long it took, if there were any errors, and an array of the items that it actually created. One of the most important things, if we're going to use this as our primary data store, we need to do some basic paging. So this happens with a GET request, but the paging data and the sorting data is actually in the body, not in the query string. And that's because you can do all sorts of advanced queries, which just wouldn't be feasible in the query string. So you use from and size to get your skip and your take. And then we can pass in an array of sort options. And this will allow us to sort by year ascending. So if we look at the results, we got some movies over here. No, 1924 is the ID. Year 1959, 2008, 2014, and so on and so forth. Obviously, you can do descending if you want to switch it around. Cool, so now we got paging and sorting. One of the things that we want to do is we want to use this great engine to do our searching. So what we can do is we can do exact matches. So find us all of the items in our database where the title has the word star in it. And we do that and we get back 2 results. The fact that it took 2 units of time, what shards it hit, and then we've got some information about our hits. So we got 2 items back. Max score is null because we specifically put a sort order on it. And we get Star Wars and we get Star Trek. Another interesting thing we can do is we can query the array. So we had a genre array. We can simply find all the items. It doesn't mean we need to treat it any different, but find us the genres that include sci-fi. So we can do that. And we've got Interstellar. We've got Star Wars again, Star Trek, and that's it. Cool. The very cool thing that you might have seen is in a website, you might want to search through a bunch of documents for something, and on your web page, highlight those results in the actual data. We can do that by specifying highlight on the actual query that we send in, which is pretty awesome. We get this out of the box for free. So if I search for star and I ask for it to bring me back the highlights, it not only brings me back the source, but also the highlight. And by default, it will put the EM tags in there. You can actually customize that if you're doing, let's say, XML instead of HTML. You could do JSON formatting in there, that sort of thing. Yeah, so that's pretty much it for using the REST API. How are we doing? 15 minutes, cool. All right, so it's all great and well being able to query our data store using REST APIs and Postman. But in production, we're probably going to want to use some sort of server. And because it's me, we're going to be using a Node.js API. So I've got an example here of how we can actually do that. So I've put some fairly straightforward boilerplate in here. There's no authentication or anything like that. What I've got is this app is for helping us to calculate how expensive meetings actually are. For those of you who have been able to work from home, you'll probably have noticed a massive spike in the number of virtual meetings that you're in. It's almost like people want you to be on Zoom, Skype for Business, Teams calls, whatever it is, 24/7. If you're not collaborating, it's not real work. So we've gone a bit too much on the other side. So we need to illustrate this to people. So we've got people over here, and I've made a generic Elasticsearch service, which we can reuse. We use the standard Elasticsearch NPM package that exists. I just pass it in some credentials, the change me password. I've got a function over here which will give me the client, which will basically proxy my REST requests. I mean, you could always use Axios or Fetch or whatever to do them yourself, but the client comes with some decent TypeScript definitions built in, so you get some decent IntelliSense while actually working with it. And then I've got my generic service over here where the TypeScript is complaining, but it works, which is another reason why I don't really like TypeScript. So we can create our service, and that will give us back an object at the bottom with all these methods on. So I've kind of made like a generic version. So it's got a function to ensure that I've deleted an index, because what I'm doing is every time I boot up my API, I wipe out the index and recreate my static data. And then I've got create, replace, refresh, which will actually go and rebuild the indexes. Because if you just add something into a collection, but you don't refresh the index, the search is not going to have been optimized. So you might not actually get that result back. So if you're going to do a bunch of bulk operations, it does add an extra layer of complexity. Then what I've done is I've added an autocomplete because I find that very useful. A get method, a search method, remove the client itself, and some mapping logic. Cool. So when the app boots up, it will go and it will create some static data for me. Now, I just wanted to show you something very cool, which is Faker.js. So I needed to create a whole bunch of fake data, and I didn't feel like manually typing it in. So this library is really, really cool. I think I still have it open here. So you can generate all sorts of fake data in these categories. So for example, you can generate names and date of births, because it's always better to actually, when you're playing around with the system, have data that looks similar to what production data would actually be. But the nice thing about this is there's no risk of actually violating any GDPR or POP. Well, I suppose there's a 1 in a million chance of actually generating a real person where all the fields match up. But it is fake data, and so you've done your best that you can. So what this does is when the app actually boots up, it will go and generate a whole bunch of fake people and a whole bunch of fake meetings. Although, yeah, are the meetings actually fake? Doesn't matter. So what I do is I've got a basic for loop with a min of 100 and a max of 500, and it'll call generate fake person, which basically does all of this stuff. So I create a property called first name, which uses faker.name.first, faker.name.last. I create some geolocations for them. I create a salary, which I used, where was it? PayScale to figure out what the average software salary of a software engineer is in the US. So I've got the min and the max in US dollars. And then I generate a date of birth between 1960 and 2002. For the meeting itself, I generate using the aptly named faker.company.bs, which will generate some corporate speak for us for the subject of our meeting. I create a fake date, and then I take that fake date, and using moment.js, I add between 50 and 90 minutes to the time, which is probably how long a meeting might take. I calculate the duration in minutes. Then I pick a random number of people between 1 and 8 to add to the meeting. Then I take the people and their salary, and I use a reduce function to calculate what that person actually cost and keep a track of the running total of the meeting. Then I calculate using the very sad ZAR exchange rate that I saw just before this, and then I set the attendees, and I actually save them into our data store. So let's go back to Postman and see what that looks like. Cool. So if we search for people, so I've translated it because I quite like using the query string for most of the time, unless I'm doing very complicated queries. So on my API, I add support for, what have I done? Added support for skip, take, and then I can pass in exact matches by the query string. And you'll see we get back the top 10 results for people. And we know there's between, what was it, 50 and 100. I can then take somebody like Jamison over there and do a search on that. And I can find whether this is an exact match search. So it's not an autocomplete. So just be aware of that. But it is very useful to do a lot of the time. I can also use the autocomplete functionality. So let's see if there's somebody in the database named Will. And we get an error code, of course, because why should you not change data before the demo? Yeah, we'll sort that out in a little bit. And then we've got meetings, similar thing that we can use, like to the people. What I'm doing is, because it's a document store and not a relational database, is I'm dehydrating and rehydrating my entities before I persist them in, because I don't want to actually, use the person's name that might be stale. So in my service over here, when I call create mapping, create over here, I dehydrate the object, which is just a function over there, which will take the attendees, map them, and extract the user ID out of attendee, and always set them to accepted because I haven't implemented that logic yet. And then when I do a search, I don't rehydrate it, which is why we see what's actually stored in the database. But if this autocomplete works, we will see, let me just cut out the query string. No, we need the query string. Let's just actually get some meetings. So we've got a meeting here with impactful engineer functionalities. So impactful is a word that I saw comes up pretty often. And I've actually now rehydrated my people on the actual query. So we can see this meeting, which lasted 18 minutes, will cost $60 roughly, or 1,000 Rand for a short meeting. We can also set the fuzz factor, which basically, the fuzziness factor, which will use the Levenstein distance algorithm to basically allow for changes in letters or substitutions or deletions of letters. So if we set fuzz to 0 and we spell impactful with an I instead, we should get nothing. If we set fuzz to 1 error, we should get our impactful meeting. So that's cool because you can actually set that via the UI. The last thing I want to show you, since we're running a little bit low on time, is Kibana. So when using Kibana, you basically, first thing you have to do is tell it which indexes you actually care about. So we can actually say, let's type in people, and that'll say, cool. And we set up our index. If you have time series data, this is very useful for logs, then you can actually choose a time field on there, and it will index it by that. So I'm going to say, I don't want to index by time. And this dashboard is kind of where you can actually see a lot of things about your Elasticsearch cluster. One of the most powerful things you can do is create visualizations. You can actually create dashboards that then use the visualizations you've created, and you can iframe them into your existing apps. Obviously, you're going to want to make sure that you set up some NAT and security on the gateway so that you don't expose your whole cluster and just the Kibana instance. So we have people with latitudes and longitudes that were randomly generated. So this should be fairly interesting. So what we can do is over here, zooms in the way, one sec. So we've got a world map. We can add a layer using our documents that we've stored on the index people. And you'll see that it picks up their location automatically and starts spreading them out on the map where we had them. So we've got quite a bunch of distributed people in our organization. Seems a lot of them have yachts or cruise ships, a few adventurers out in Antarctica. So this is how you can very easily do a bunch of maps. What we can also do, let's leave the page, we can go back to our indexes. Nice little loading bar. Let's add an index for our meetings themselves. Let's create a new index pattern on meeting. You'll see it's a regular expression, so don't have to be too accurate. Create that. We can go again to our visualization because visualizations are always very cool. Create a new one. Let's do a bar chart this time using meetings. So the y-axis is currently set to the count. Let's bucket it along the x-axis. We'll use a histogram on the South African Rand value of the cost. And let's split it up into buckets of 1,000 Rand. You can hit the little play button over there to see how it looks. So once again, zoom, just move it out the way. So if I look here on the x-axis, we can see that there are 3 meetings that cost between 0 and 1,000 Rand. And if we look at our most expensive meeting, cost us 8,000 Rand. So if you think about how many meetings are happening in parallel in the average office, or at the moment on Zoom, Skype, all of those things, and we ignore the electricity cost, because people always want to talk about crypto and how much that costs electricity-wise. Let's talk about Zoom meetings and all of that, and how much they actually are costing us. Just in terms of salaries of people, we can find out that this is pretty high. Cool. So how much time? I think I got like 2 minutes. I'll just quickly show you the what was it? Deja vu. So deja vu is kind of like the closest thing that I've found to the SQL Management Studio. Here we've got the people collection, and I can actually drill down and I can edit data, and there's a date picker, and there's also a nice bulk importer over here, so you can use CSVs and that sort of thing. All right, Jerry, I guess I should stop sharing my screen and we can answer some questions, or should I keep sharing? Thumbs up or down?
Sure. So you can leave your screen shared if you want to, because I don't know if you might need it for answering questions. But let me start with the questions. Okay. As I said earlier, for those of you who may have joined a bit later and missed it, the live stream is a little bit delayed. So please post your questions on Slido, and we will try to answer them. If we miss any of them for Ryan now, we'll answer them at the end.
Yeah.
So,
or you can open a GitHub issue with your question.
Yeah. Cool. So Ryan, first question, most popular question. What VS Code theme do you use? It's amazing.
Okay. Thank you. It's not all my work. I will properly attribute the lady on Twitter who basically put together a Twitch stream of how to set it up, which was about an hour long, when all I really wanted was a file that I could just copy. But I sat through it, and it turned out to be quite an enjoyable talk. I will also set up links for that. So it's Synthwave. Let's just see over here. It's Synthwave times Flora Machine, but I've added a bunch of customizations in the style sheet. So if I go to settings and we view the JSON, if I can see the button when zoom's on the way. So formatting, syncing, navigation, look and feel. So I customized the style sheet a bit. So I'll put all of that in a GitHub gist for you and send it out.
Awesome. Cool. Next question. Do you get any performance problems using HTTP as your primary mechanism for querying and transacting?
Great question. So you'd think, like, you've got to hop from your web server or your browser to your API server, because you're probably doing some sort of REST API on your side. Then the hop from your API server to your data store. And your gut feel would be like, hey, well, this is actually going to take quite a while, but it's actually very well optimized for this. And what I've found is, as long as it's in the same data center, it works really, really fast, even with big volumes of data. I mean, if you think about it, you're probably not going to pull like 100,000 records back to your front end. If you're going to pull data back to your front end, you're probably trying to do some sort of graph, in which case you could use Kibana. Or you might want to actually aggregate it on your API itself before sending it back to your browser. But as long as you do paging in that, I've found with even big numbers of data, it's great. It's not. I haven't noticed a performance problem, and that was on a small Kubernetes cluster in Azure.
Cool. Awesome. And then last question. Sorry, my phone is refreshing. Underscore mapping, underscore doc. Are these Elastic specific commands to perform specific functions? Where can I learn more about them?
Underscore mapping and? Oh, in the URL. Yes. So
in the URL, yeah.
Yeah, so that is, in fact, yes, it's part of Elasticsearch. I thought it was Lodash for a second. So if you look for Elasticsearch mapping, it actually documents all of the different parameter types that you can actually set up on a mapping. So we've got the data types, text and keyword. So text is if it's a long paragraph of text. Keyword is if it's more of a short thing like a genre. We've got dates and then the number data types, IP addresses, geolocations, as well as shapes. So these are the sort of the primary ones that you would set up on a mapping, which, just to refresh, looks like. So it's definitely an Elasticsearch convention where you post or put to the actual index /_ mapping, and then you put your actual sort of like JSON schema type object in there. And
awesome.
Same with doc. Yeah, that's an Elasticsearch convention.
Okay, Awesome. Thanks a lot, Ryan. If there's any questions, you'll be here. Any more questions, and we'll ask you again at the end.
Cool.
Next
I'm going
up,
to have a beer now.
do it. Next up, we have Mike with performance. Lighthouse. How to Lighthouse. That's the one.
Thank you for the sparkling introduction, Jerry. Let me just get everything ready this side before I share. That's the end. Let's go to the beginning. Okay. Share my screen. Hopefully I can pick the right screen this time.
I mean, it wouldn't be us if we didn't like make some mistakes in the process, right?
I kind of feel like I need to ask everyone if they can see my screen. Does that look like a presentation to anyone?
Yes, it does. We can see your presentation.
Thank you very much. So hi, I'm here to talk to everyone about how to Lighthouse. So for those of you that don't know me, I'm Mike. I'm a Google developer expert in web technologies. I've been one for a few years now. I'm not sure why they enjoy keeping me around. I think it's my propensity to apologize for things, particularly JavaScript's weirdnesses. But I mean, it's relatively open-ended. So if you need to blame anyone for anything, I'm prepared to take it on. I am also a core contributor of the HTTP Archives Web Almanac, which is an incredible resource talking about the state of the web over the course of a year. Some really, really smart people have written some very insightful stuff about all sorts of important trends on the web. I am not one of those smart people. I am the guy that looks after the plumbing. So yeah, that's me. And oops, you may also know me from here, from Jozi.js, where I'm a core organizer. We miss our physical venue, and we miss seeing all of you in Meetspace. And we're really trying to make this all work. And thank you for being on this journey with us. So as Jerry alluded to, we're here to talk about performance, right? And the thing about performance is, as much as it has such a massive impact on how our software operates and how it gets used and how it gets perceived, it often doesn't get prioritized very much, and it's very difficult to talk about with business. So to start off with, I'm going to go through a very brief couple points on trying to convince people or give people arguments about why you should care about performance. So perhaps the first reason why you should care about performance is for competitive advantage in business, right? There's been research done talking about the idea of a just notable difference of 20% in terms of if you're 20% faster than your competitor, that's significant enough that people recognize it and it becomes a thing that sticks in their mind. Conversely, if you're 20% slower than your nearest competitor, they also remember that. So maybe you can use that to convince people that they should care about performance of web applications because you get a benefit from it. Maybe it's because of search engine optimization or any kind of Google page ranking, where the first priority is obviously content, but the second thing that gets looked at in terms of ranking pages is speed, speed in mobile especially. And if you care about any kind of search engine optimization, maybe don't hire the expensive snake oil peddlers and just make your site faster. Or maybe you are somebody who's developing for our context, right? We don't have the most amazing internet ubiquitously. We are an emerging market, and there's a lot of compelling research that indicates that speed is a key differentiator for building for any kind of developing ecosystems. Now, maybe I can also appeal to something more base in us as programmers. Now I'm going to talk about Larry Wall's 3 great virtues of a programmer. Laziness, which is wanting to limit duplicate work or wasted effort. Impatience when a computer is being slow and you have to sit and wait. But the third virtue of a programmer, I think, is the most relevant, that one being hubris. Because maybe you just don't want people to say bad things about your website because it's slow, right? I don't know, whatever, let's roll with it. Now, to get started with this journey, I'm going to talk to you about Lighthouse, which I feel is a very, very important central point that brings a whole bunch of performance stuff together. Okay. So what is Lighthouse exactly? Well, it's a whole bunch of best practice guidance that has been rolled up into a very simple, easily actionable set of audit responses. It sees a thing and it tells you how to fix that thing, or as close as possible. And it then takes those responses and it generates heuristics for you in terms of simple aggregated scores. Now, those scores are really easy to understand and really easy to see, or maybe less easy to understand and far easy to see. And it becomes something that's very easy to share with business. Importantly, Lighthouse is not just tooling for you, it's also something that gets used in page speed insights and a whole bunch of other very important speed tooling across the web. Okay. Now, when we try and understand what that score means, we need to look at a whole bunch of key metrics. These metrics are sort of timing points in the life cycle of your page, from first contentful paint, first meaningful paint, CPU idle, time to interactive, speed index, and estimated input latency. Before we talk about the specifics of what we're measuring there, let's take a look at how the weightings affect the Lighthouse score. Now, from the documentation, it says, well, first contentful paint is 3 parts of the score and time to interactive is 5 parts to the score. And it sounds like we're making a recipe of some kind. So I prefer to break it down in terms of percentages. And if you look at percentages, first contentful paint is 20% of the score, time to interactive is about 33% of the score, and speed index is about 26.7% of the score. So those are the big chunks that we're going to focus on today and we're going to talk about. And at this point in time, I feel like I need to give you a caveat, which is to say that these performance scores change continually over time as they try and mutate people's behavior and understand how to best measure one's Lighthouse score. So if you go in 2 weeks' time and they've changed the scoring again, just don't blame me, okay? So the first important timing event that we care about is first contentful paint. And that's basically the time from when a page starts loading, so the blank screen, to when any part of the page's content is visible. Now that's really important because that's that flash of white screen that you see when you're like, well, I don't know what's happening. Is the page loading or isn't it? So it's a really important user-facing metric. Speed index is a little bit harder to nail down and explain tersely. And speed index is basically like the progression of how things are visually displayed during the loading of a page. And you can think of it like this visual progression between frames that gets aggregated as just like this many seconds. So it's hard to understand, but it's also really important so that people can see the page changing. And then the last one that's really important to us as JavaScript developers is that this idea of time to interactive, which is the time from when a page starts loading to when it's done all of its bits and pieces and it can reliably respond to user input and the JavaScript can execute. And this is really important because as we write these heavier and heavier JavaScript applications, is looking at your React, it shows or it helps highlight when the page looks like it should be interactive, but it actually isn't really responding yet. Okay. Now, another way of visualizing it is using the 3 questions, and those 3 questions being like first paint and first contentful paint. Is it happening phase? So is something happening? Can the user get the sense that the page is doing stuff? Now, first meaningful paint is in the is it useful stage. Can I start reading some content? Is there anything I can engage with just from an interest perspective before I can do stuff with it? And then the important one being time to interactive is it usable stage? So the user is expecting to be able to smash on buttons and not wait any further. All right, but I'm far more a show, don't tell kind of person. So I'd like to go through a little bit of a demo, which you're going to have to stick with me for. I hope it works. I am going to just go here. And my demo is a very little meme generator app. It's something I repurposed from a previous talk where I can go and generate Lord of the Rings memes for any appropriate situation. And I think it's important that you know that I believe that there's a Lord of the Rings meme for every situation. But there's this little app. And this is just DevTools open to the right-hand side that I think everyone can see. Let me just zoom in a little bit more. So this is the pane that you're normally used to seeing. And you may have scratched back here and seen a pane like this, which is the audit report. Now, this is the core Lighthouse report that typically comes with everything selected. Okay. So I'm going to disable everything just so that it runs a little bit faster. And I'm going to generate a report. And it's going to go and, oh, wait, I've catched some stuff. Huh. Demos never go well. Okay, let me just stop this all, tear it down.
It's because you were changing your demo 3 minutes before this started.
You're not supposed to tell everyone that. Okay, hopefully.
It's recorded now, I'm sorry.
It's recorded, it's done. Localhost, 3001 public. Let's go back, quickly back. Generate. Thought I tested this. No, I broke it. Am I in the right folder? Am I serving the right thing? Console network. Disable the cache. Oh dear, oh dear, oh dear. Let's just see that's there. Do I have the right webpack? Yeah, I've got the right webpack. I ran build and I ran start, right? This is very typical, right? Window, go across. Sorry, everybody. There we go. Now I broke it. I think for whatever reason, because I was testing stuff just beforehand, it must have cached it. You can't see them, but everyone is busy laughing at me on the Zoom call. Okay, so thanks everybody. Thanks for the comfort. Okay, so for this super simple little React application, we have a really poor score comparatively at 66. And it says, well, here is our first contentful paint and meaningful paint and speed index and time to interactive. And they're all really similar, which means that there's this log jam before things render. Okay. Now down here, you can see there's a whole bunch of opportunities for things that can fix, like images can be changed, text compression can be enabled. Now that's not going to be there because I'm running locally. And there's also this keep request counts low and transfer sizes small, and I'm delivering a monolithic 2 megabytes worth of content, of which 700 kilobytes is JavaScript, right? Which is far too much for this tiny little app. Now I'm just quickly going to go into Trace here because this is a high level report on it, but you can go into the super in-depth Trace report that shows like the CPU timings and events, and you can see the progression of frames here. So there's this little screenshots thing. And as you go, you can see there is our DOM content loaded event, our loaded event, our first paint, our first contentful paint. And here, when it starts showing the images, it records first meaningful paint, okay? Which is quite cool. And then there's all this timings and main stuff, and there's GPU time and a whole bunch of stuff. And maybe when I'm big, I'll understand this, but for the moment, I'm just going to close this panel because it's confusing. Okay. So for us mere mortals, we need a little bit more guidance to try and start unpicking this thing. Now, knowing what I know, I've got a distinct suspicion that this is stuff that I want to take a look at, but for our time to interactive score to reduce, we're going to have to reduce how much JavaScript we execute, right? And to do that, we're going to need to scratch around. Now, there's this little known feature in Chrome DevTools, which is that you can run a code coverage report. So if you go into more tools coverage, right, and then you push this little refresh button, it will, for all of the stuff that it downloads for the page, it'll figure out how much of it you're using. And you can see that 56.5% of that JavaScript bundle is completely unused, right? Which is pretty awful. Now, the nice thing about this is that it'll also show unused CSS and that kind of thing. So it's a very useful little tool. And it also will go into this JavaScript, and you can see, well, the red lines are stuff that's unused. But unfortunately, it's all bundled and minified. So not very useful to us, right? I mean, I don't know what that's even doing. So yet again, we have to dig a little bit further, okay? But we've at least got a good idea that JavaScript is something that we can take a look at. Now for this, I'm going to include in our package something called Webpack Bundle Analyzer. Now I've installed it already, and just so that we didn't wait for that as well. And if we look at running Webpack with this -- profile and -- JSON command, we can generate the stats.json, which is just going to be the build output of the Webpack package. And then we can go to Webpack Bundle Analyzer on that stats.json file. And then we end up with this view, which is completely unhelpful. And you're like, yes, that is my big bundle. But what you can do is you can go into the side here and pick the stats and then show content of concatenated modules. And then suddenly Webpack Bundle Analyzer will tell you what everything is broken up of. And I can see that the biggest part of this bundle is material UI. And there are a whole bunch of stuff here that I'm not using in material UI. And this is a common thing that we see is unused elements being used in our applications, right? So if I close this down and I go and take a look at that, I now know that this button here is the only place where I'm using material UI. And it's really not important on first page load. Oh, oops. That's supposed to go to public. Oops, something like that. I broke it. Oh, because it's not running, obviously. Okay, so let's close it. And luckily, this is actually a really easy problem for us to fix, right? Because if we go to our simple React application and in our app.js, here at the bottom in our render method, we can see that we're conditionally showing the new button, right? And this new button is the offending thing because behind here is where all of the material stuff sits. So what I'm going to do is I'm going to just simply break that up into a separate bundle and lazy load it, which sounds complicated, but it actually really isn't. So for that, all I'm going to do is I'm going to create a new const new that's going to represent our new, and then we're going to call react.lazy, and then pass it a function, and that function is going to use a dynamic import. Okay. And out of that dynamic import, it's going to be for this component over here. Just copy and paste that in here. And Webpack is going to know that the dynamic import is going to result in a new bundle for this, and that it needs to lazy load it. And this is just a component that React can understand that we can use further down below. And it would be nice if this worked just like this, but unfortunately it doesn't. We additionally have to import something called suspense. And around our new method at the bottom here, we need to create a suspense object. And the reason why we need to create a suspense object is to give it some fallback stuff. So I'm just going to create a little div, and that div is going to be loading or something. Okay, so that's my fallback div. And then at the bottom here, I'm going to create the suspense object, reformat stuff. And unless I've made any typing mistakes, that should just work. Now, if we go back and we go npm run build, which is going to run, oopsie, npm run build, which is going to run our Webpack build. Into dist folder, and then we're going to go npm start. And then go back here to our application that should hopefully by then have started working. Hey, what do you know? Go back to our audit tab and run a new audit now. Just reload, make sure that's all fresh. And we see a pretty smart jump, far too much of a jump, actually. I think I might have broken it again because that's supposed to be the final, but I'm just going to roll with it. It's a pretty smart jump in terms of bundle size. That was supposed to be about 86%. So the rest of the demo is not going to make a big difference. But if we go to Webpack again, so let's rebuild that. Let's just go to Webpack Bundle Analyzer, and we can check it out. Is it? Why is it not showing the multiple modules? Okay, there we are. There we can see there's now the two modules, index and index.1, and they're roughly of equal size, right? So this is the first one that gets loaded, and then index.1 will be lazily loaded in when you click the button. And just to convince you that I haven't broken anything, like, oh, I have broken stuff. Something's not working exactly right. I must have mistyped something. Oh, because I stopped it again. Oh dear. Anyway, okay, so let's just move on with that. So that's a big part, but there was also other stuff that we could take a look at. Now, a common mistake that gets made in terms of Webpack configs is that here we are doing this Babel preset env preset react, which essentially means that we are rendering some of the oldest versions of JavaScript, right? We're rendering ES5 JavaScript typically. But we can do some smarter stuff for smarter browsers because Chrome has far more modern versions of JavaScript available to it, okay? So for that, we're going to want to do something called differential loading of JavaScript. So we're going to say, well, for older legacy browsers, we'll ship ES5 code, but for more modern browsers like Firefox and Chrome and Edge and that kind of thing, we are going to generate a modern bundle. And how you do that is pretty simple. So we're going to create this base Webpack config, and we're basically just going to smash all of this stuff to start into the base. Okay. Then we're going to create a const legacy Webpack config and a modern Webpack config. Okay. And to generate these, we're going to use some shared base stuff and then merge in modern changes. So for that, we're going to use something called Webpack merge. And we're just going to use Webpack merge. And then for our legacy, we get to merge in base with something. And then for modern, let's just do it like that. We get to merge in base with something. Okay. Now, to make up some time, I'm just going to overwrite these. So the Babel stuff is the important bits and pieces that I don't really care about in the base anymore, because that's going to be different between the two. So I'm going to strip out the Babel config. We'll leave the CSS loader config in base, leave the copy image plugin. Then for our legacy, it's actually going to look something like this, which is going to be essentially the same as we had previously. And for our modern, it's going to look something like this. Oh, that's legacy. This is modern. Where it looks very similar, but we're going to say instead, we want to, that's because that's exactly the same. Oops. What have I done? There. That's legacy. Here's modern. Whatever I did it twice consecutively. It's been a long week, okay? All right. Whew. So what we're going to do is we're going to configure preset env to say, well, we want any browser that's got a more than 0.25% market share and not Internet Explorer 11. So we can use modules. Okay. And then to export it, we're going to say we're going to export legacy and modern. And exporting it as an array rather than as a simple object, Webpack understands. And when we npm run build, it will generate two separate bundles. And I'll take a look at that in the public directory now. It's going to generate two separate bundles, one that exists inside legacy, which is index 1 and 2, and then one that exists inside modern, which is index 1 and 2. And if we take a look at the dist usage of that, so if we look at what's it, du-ah public JS, we can see that the primary index.js, so that one in legacy is 236 kilobytes, and in terms of modern is 156 kilobytes. So we've shaved off a neat 100 extra kilobytes of JavaScript just via that. But this is not enough to be able to load it up in the browser. To load it up in the browser, we need to go into our index.html that's responsible for loading up the script. Okay. So this is the thing that's responsible for loading up our application. And in here, we can do the following. Okay. So on our script type text equals JavaScript, we'll say, well, we're going to put the no module directive on it. Okay. Which says that only execute this if no module is available. And on our other directive, we're going to say script type equals module. And we're going to say source equals JS legacy, sorry, modern index.js. Close that up. And then we're going to add legacy in here. Now, browsers that don't read the no module don't understand script type module. So they ignore this directive. So if you're running Internet Explorer 11, it's going to hit this line of code and run the old JavaScript. Okay. Browsers that do understand script type module also understand no module. So Chrome, Firefox, Safari, etc., are not going to run this line of code. Okay, and only run the modern code. So if we then npm start this, because I broke my demo a little bit earlier, copy pasting the wrong thing, let's reload it. We're going to run another report. And it's going to give us the same score. I'll figure that out a little bit later and we can figure out what's gone wrong. Then, in the interest of time, because I'm a little bit concerned about it, I'm going to skip the image optimization stuff, which is also pretty easy because you just include it in terms of your Webpack config. And I'm going to go straight onto running Lighthouse as a CI. And for that, I'm going to go into my package.json, or no, my package.json, sorry, my folder structure. And I'm going to create something called a lighthouse rc.json file. If I can spell Lighthouse. That sounds like something completely different. Okay, a lighthouse rc.json file. And inside that file, I'm just going to copy and paste in some JSON. And that's going to say, well, our collect URL for the CI is localhost 3001/public. I don't want the PWA stuff, and I'm going to disable a whole bunch of things, but I'm also going to specify that my performance category, my minimum score is 0.99. Okay. Then I'm going to go to my package.json, and I've already installed the Lighthouse CI dependencies, and I'm going to create this Lighthouse task. And for my Lighthouse task, I'm going to do Lighthouse CI auto run. And just double check that I typed that name right, lighthouse rc.json, correct. Now I can npm run Lighthouse, and this will take a while. So basically what it's going to do is it's going to use the default configuration, which is going to run Lighthouse 3 times consecutively, and then report the average of those 3 runs. And it's taking time, and it's taking time, and it's taking time. And it's taking time, and it's taking time.
We can answer some questions while it's going.
I can, while it runs. That's a great idea. That's why you moderated, Jerry.
There is only one question for you so far. So all of the optimizations, these are very Webpack specific optimizations. Do you know of any other tools that can do these things?
So Webpack Bundle Analyzer is the only Webpack specific optimization. And the reason why, I'm not sure why this is taking long. Oh, I know why it's taking long, because it's not running. the site needs to run. The reason why this is Webpack specific is because it's the de facto standard, but there's nothing that prevents you from using Lighthouse on a conventional site or anything that uses Parcel.js or Rollup or anything else, right? You can use it anywhere. Does that answer that question?
I guess so. I guess we'll see. There might be a follow-up question. Okay.
Okay.
Okay, so next one. Can you use suspense for stuff other than lazy loading dependencies? Example, fetching data.
No, I believe suspense is the primitive for falling back when lazily loading. I suspect that it exists just for that reason.
Okay.
But I stand to be corrected. Yeah.
Okay. Cool. And this last question, may you give an example of websites using Lighthouse?
Well, Lighthouse is tooling to measure the speed of websites, right? And I'll give an example for that. Let's put a pin in that. I'll put some resources at the end that I'll talk about. Okay, so it's finished. And for whatever reason, it's picked up a 99% pass score. So it's succeeded. Now, this takes quite a long time. You shouldn't run it like this necessarily yourself constantly. But the point behind Lighthouse CI is to be used in the context of a continuous integration server. So like every commit, you can run this command and make sure that you haven't regressed in your Lighthouse score. And then there are integrations for a whole bunch of different popular CI servers. Okay, so with that, I'm going to move back to slides and close out. Okay, oops, sorry, I should have hidden that. Great. So in conclusion, I think it's really important for us to understand the key performance events of our page, like how does the browser see these things happening and fitting together. I think it's really important to develop a deep understanding of our tooling and the options that are available to us, and to keep a razor sharp eye on what is the critical path for our users, like what's the least amount of content that they need to have visible, and cut everything away and apply Occam's razor very carefully there. I didn't do it today for whatever reason, because the demo fails, but you should make small measurable changes. Take each one and make sure and validate that it works before making the next one so that you know what changes are happening. Otherwise, it's very easy to gloss over some things that degrade performance. That, and I feel like automation and monitoring should be essential for this performance stuff. And I can recommend Lighthouse CI and some of the tooling, but there are other options like Speed Curve or Page Speed Insights itself. Now, before I leave you, not before I leave you, I've lost some slides. Oh, I lost those slides. Okay, doesn't matter. I'll post some links to web.dev /FOST. And in fact, let's just do that quickly. I can strongly recommend that you take a look at web.dev /FOST, which is Google's web education information about making your site FOST, as well as being the coolest URL name on the internet. And they've got this measure tab as well. This is Lighthouse, where you can sign in and you can say, well, this is a URL that I care about, monitor that over time. So here's an example of Lighthouse embedded into a page. And then the last one is Smashing Magazine front-end performance checklist. And I'll post these links into the live chat in a bit. This is a super, super, super long read, but everything that you need to know about the state of the art of performance is in this one article. So don't listen to me. I know it's too late, but don't listen to me. Go and read this article and you'll understand everything. Okay. And I think that's me done. Are there any other questions?
There aren't any other questions so far. However, we do have
lucky.
one more question for Ryan.
Okay, can we finish with Mike's question? I have a very simple and quick question. Mike, how early, so you spoke about how you can integrate this into your CI/CD. How early in the project development cycle would you start looking at things like performance, and specifically how early would you start using Lighthouse and integrating it into your CI/CD?
Right. So the ideal answer to that is obviously before you start shipping any code, right? So determine what your performance metrics look like before you have an MVP, and then you can never regress. You can always stay fast. And we've seen that work very successfully. But I'm also going to ask it, or I'm going to answer it with something that you didn't ask, which is that it's never too late to start looking at performance stuff. So don't think that, oh man, my site's so slow, I'm never going to be able to unpack this stuff. It isn't, it's hard. I'm not going to lie to you, but it's definitely possible. And then a question for Ryan, and I'll stop speaking.
Yeah, so there is one more question for Ryan. Is there a full tutorial on the Elasticsearch concept?
Yeah, so I am going to post on Twitter the link to the Udemy course that I used. I see he has updated it from version 5, which is what I bought back in the day, to version 7, which I would recommend you start with now. So I will post that on Twitter and in the question and answer program that we're using.
Awesome. And that's
sorry,
actually...
just there's probably also a bunch of really good free ones. I just bought that one, so that's the one that I can actually personally recommend.
And that's actually a potential idea of anyone who's online who knows Elasticsearch. Here's a talk for you to submit to our meetup. Awesome. So I don't know if there's any more questions. We can wait like an extra 20 seconds and just talk about JavaScript because the live stream is delayed. I mean, like we can talk for more than 20 seconds about JavaScript. I think between the 7 of us, we could probably talk for hours about JavaScript. But maybe we shouldn't because people need to do other things with their lives. Yes.
Please submit feedback. We're all figuring this out as we go. We have, and if it hasn't become categorically clear by now, we have no idea what we're doing. So please give us some help. Okay.
Yeah.
Thank you.
Yeah. Please fill in the feedback form.
To Ryan's statement to post the tutorial stuff on the Slido, I think it might be better for you to post it on maybe the YouTube stream somewhere in the comments somewhere so that people can pick it up.
All right, let me do that now.
And we will post the feedback. The feedback URL is in the description of the YouTube channel that you're currently watching. So please go click it. And if you have any other ideas, if you know of any other ways we can do this, we're welcome to any suggestions.
Yes, and we are constantly looking for people who'd like to share their knowledge on anything web related. So if you'd like to give a talk similar to the ones that you've seen today, or even if it's something completely different but web related, please feel free to submit. And if you would like some help beforehand, maybe preparing or getting some tips on how to do this online speaking thing, we've got a panel of really experienced speakers here who would be more than willing to assist you to get ready. So please don't hesitate to tweet either one of us, to DM either one of us, submit through the link that we've posted on this YouTube video that you're watching right now. Yeah, we look forward to hearing from all of you.
And even though we may be experienced speakers, we still get nervous when we speak. Like, I forgot everything I was going to say when I started earlier. So don't worry, we're all in this together. We can figure it out as we go, as you saw. When you miss your sacrifices to the demo gods, your demos don't go well. It happens.
Someone specifically mentioned that Mike forgot his sacrifice to the demo gods on YouTube.
And
I
stay
did.
safe,
I really
everybody.
did.
Yeah, wash your hands.
Wash your hands.
Wash your hands.
Stay away from humans.
All right, there doesn't seem to be any more
Bye.
questions. So I think that might be us. Thank you to everyone who attended. And we look forward to reading all of your feedback.
Yes, we do. Bye.
Who's clicking
Bye,
the end?
everyone. This was fun.